Previously, we were doing examples where we always knew what the angle was, and we were trying to find an unknown side length. This time, we're going to be finding an unknown angle when I know the side lengths. So let's go ahead and take a look at this example. So here, I do know that this angle is 90 degrees, but I do not know my other two angles. So let's say that I want to find this unknown angle that's labeled theta, and the information that I'm given is 6, which is opposite that theta, so we could label that as my opposite. And then 12, which is across from the 90 degrees, so I could call this my hypotenuse. And we're not told this other leg right here. I could actually find it by using the Pythagorean theorem if I wanted to, but we're just going to focus on finding this angle right now. So since I labeled the 6 as my opposite, that's my opposite, and then the 12 as my hypotenuse, I have my opposite and hypotenuse involved. And that's going to be what tells me what to use, whether I use sine, cosine, or tangent. So since I have my opposite and hypotenuse, then I'm going to come over here to my SOHCAHTOA and say, well, what do I have? I have an O and an H. And so that means I'm going to be using the S, or this sine. So I know that I want to use the sine function. And anytime you write any trig function, whether it's sine, cosine, or tangent, anytime you write any trig function, it's always followed by an angle. And whether you know that angle to be an actual degree, a number, or whether you don't know it and it's an unknown like theta or alpha, then it always goes after the trig function. So sine of an angle. So that's going to be sine of theta. So sine of the angle theta is equal to O divided by H, so opposite, which is 6, divided by hypotenuse, which is 12. Okay, now remember, my goal is to get theta completely by itself. So essentially what I want to do is I want to somehow get rid of this sign. I want to somehow undo that sign. So what we need to do is we need to think about inverse operations. I went ahead and I brought in a picture of a calculator here so we can kind of get some help finding what the inverse operation is. And again, what are inverse operations? So for example, subtraction is the inverse of addition, dividing is the inverse of multiplication, taking the square root is the inverse of squaring. So inverse is something that undoes something. And I'm looking for what will undo taking the sign. And on this calculator here, if I find the sign button, so here's my sign button right here, and you'll see what's kind of in blue right above the sine function, and that's sine to the -1, which is the inverse sign, which is by definition the inverse operation. So just like I would subtract to undo addition or divide to undo multiplication, if I want to undo the sine function here, then I'm going to take the inverse sine. And when I take the inverse sine of theta, then those two things cancel each other out, and I am left with just theta like I wanted to. But anytime you do something to one side of the equation, you have to do it to the other as well. So I'm going to go ahead and take the inverse sine of the right side as well. So when I'm plugging that into my calculator, if I want to use the inverse sine, let me erase this here. So since I want to use the inverse sine, what I'm going to do is I'm going to press the second button and then the sine button. And when I press the second and the sine button, then that will use the inverse sine. So I'm going to go ahead and press second and sine to take the inverse sine, and then I'm going to plug in 6 divided by 12. And when I take the inverse sine of 6 divided by 12, I get 30. And remember that that was theta, or the unknown angle, so I'm going to call it 30 degrees. Okay, so now I can come back here into my triangle and say, well, that unknown angle, well, that was 30. And by the way, if we wanted to find this other angle up here, then I could just go 180 minus 90 minus 30, and then that would be 60. And then this last unknown side, I could either use a trig ratio or the Pythagorean theorem to find it, and then I would know everything in that triangle. Here's another example where I'm trying to find an unknown angle. So I want to know this unknown angle theta. Let's take a look at what the sides I'm given and what kind of names I could label them. So 5 looks like it is directly across or directly opposite the theta. And then I know that my hypotenuse is unknown here. So my hypotenuse across from 90 is unknown. So then that means this 20 is a leg, and that must be the adjacent. So I am given the opposite and the adjacent. So I have an O and an A. And so I'm going to come up here to my SOHCAHTOA, and I'm going to look for, does the sine, the cosine, or the tangent deal with the opposite and adjacent? And it's the tangent that deals with the opposite and adjacent. So now I know that tells me right off the bat, I'm going to be dealing with the tangent. And anytime you have a trig function, sine, cosine, or tangent, always followed by an angle in that parentheses. So it doesn't matter whether you know that angle or whether it's unknown, but it's always the angle, never a side, that goes in that parentheses. So it's going to be tangent of, in this case, my unknown angle right there. And I'm going to say that is equal to the opposite over adjacent from the TOA. So from this guy right here, I want to write the opposite, which is 5, over adjacent, which is 20. And we kind of learned from that last example that I'm going to need to squeeze in an inverse trig function. So I went ahead and just left the space right off the bat this time so that I can squeeze that in. And now, again, my goal is to get theta alone. So my goal is to have only theta on the left side. So I wish I could somehow get rid of this tangent. How do we undo a tangent? Just like we subtract to undo addition, divide to undo multiplication. To undo taking the tangent, then I'm going to take the inverse tangent. So I'm going to take the inverse tangent. And what that will do is the inverse tangent and tangent will cancel each other out, and I will be left with just theta like I wanted. However, if I take the inverse tangent on the left side, then I have to do the same thing on the right. I have to do the inverse tangent on the right. So now I have inverse tangent of 5 over 20. And we can just go ahead and plug that into the calculator. So inverse tangent of 5 out of 20 is 14. And this time it's not a perfect, it's not a whole number, but that's okay. It's going to be 14.036. I'm just going to round that to 14.04. Since it's an angle, I'm going to go ahead and put my degrees there. And there is my unknown angle. Okay, we'll do just one more. And here I just went ahead and labeled our unknown angle as alpha, just to kind of switch it up a little bit. And let's go ahead and see what kind of names I can come up for these sides. So first of all, I know right across from 90, well, that's going to be my hypotenuse, so I can go ahead and label that my hypotenuse. Okay, and then the 2 is not opposite alpha, so over there would be opposite, but that's not what we're talking about. So that 2 is going to be the adjacent. So what I have is an A and an H. So I want to look at my SOHCAHTOA and say, okay, does sine, cosine, or tangent deal with A and H? And it's my cosine. So I'm going to go ahead and say cosine, and I wrote a trig function, so immediately it has to be followed by an angle. So whether it's known or unknown, that angle, alpha. Okay, so I have cosine of alpha is equal to, I'm looking here at the ka, so that's going to be adjacent over hypotenuse. My adjacent is 2, my hypotenuse is 10, and I went ahead and left a little space, kind of just thinking ahead here. My goal is to get alpha alone. So that would be really nice if I could get alpha alone. So that means I need to get rid of cosine. I need to undo cosine. I might look on my calculator for a hint on how to do that, and I would see that right above the cosine, button is the inverse cosine button. So taking the inverse cosine of cosine will undo itself, and I will be left with just alpha, which is what I wanted. That's the unknown angle. And if I take the inverse cosine of the left, then I have to take the inverse cosine of the right. So now I just go ahead and run to my calculator and take the inverse cosine of 2 over 10. And when I do that, I get 78.46. So 78.46, this is an unknown angle, so I'm going to put my degree there. And I've got my solution.